Okay, my recording from last time ran out of room on the drive, so I've brought this back to the facing routine, which is where I think it left off. So we are going to start in with the rough and the finish of this. So I need to be in Alt-1, my top view, right? And then because of the lathe, we need to be in plus D plus Z, so that'll be the construction and the tool plane. So I want to see this as plus D plus Z for the diameter and the Z value. All right, so setting up for the roughing pass then, lathe tool pass, rough. We're going to pick up our chain boundary, and then this is the view where it's in wireframe. I'm not really seeing that segment. So let's bring it back over. Dimmed has a little bit more, still not really letting me select anything. Still not finding a selection. Come back over to the view. Entry point or chain on the boundary. And let's see, make sure that I have the chain. And then I guess better check. Still not picking that up. And then pretty much the same thing that I always do when I'm working in a solid. Lathe toolpath, rough, and it changed over from wireframe, and I was still trying to select my partial as if there was wireframe geometry there. We need to switch over to solids, and then now that finds the cross section through the center of the part, or actually where the top plane intersects the part. So that was that reason why shifting this front to back had those negative effects. All right, so we'll go from point to point. All right, we're going to stay with our tool 1. And the feed rate, let's bring that down to 4 would be okay, 5 is okay. 5 thousandths of an inch per revolution, spindle speed 400 constant surface speed, max of 2000, and then this is going to be the rough. And if we want to change the home position, user defined, 10 and 10 is quite a bit away. Let's go 5 since we're not that much, just enough that we can verify the clearance, that the turret will index without any collisions. The roughing parameter. Right, so depth of cut, we're going to bring that down to 50 thousandths. Okay, not half an inch, 50 thousandths, minimum cut of 1,000th, stock to leave 10 thousandths, 10 thousandths. Exit amount to have it overrun, or we can go over to the lead in, lead out and have it extend. So lead out extension, we'll give it enough for the parting tool if we need it. So let's go 150 thousandths, usually going to be using an 1/8 inch or so. And we'll go ahead and accept that one. And go ahead and hit OK. Alright, so that finds the geometry, a couple passes, and comes out past the end of the part before it retracts. Alright, so then the lathe finish, and let's back up one real quick, is on the rough direction and angle. That wasn't it. Oh, I was looking for the plunge parameters. There we go. So how is it going to find the geometry? Is it going to be able to dip into those? And also looking at this first pass is going to be very deep. So we're not going to let it go in. I don't have enough in clearance on the tool to dive very deep into those pockets. But if I could set one of these to allow it to remove material along the z-axis, remove material. Oh, sorry, this one's in both. This one's along z. This one's just in x or along the face. Okay, so we'll leave it with none. And then this rapid and kind of inside of the stock thing, we're going to use the stock for the outer boundary. And when I hit OK and regenerate, Now we're going to see at least a couple more passes that's going to remove that material out to the stock size. So watch out for that disable and make sure that there's enough going on there. All right, so as the stock boundary gets updated, I'll go ahead and turn off the display. That was the last cut. As the stock geometry gets updated, then the next one will be able to follow that contour. So this is going to be a finish pass. And if we have the last, no, it was just reversing. So if I did happen, usually I'm going to pick by habit to the far right so that the arrow is going that way. If I pick that way and get it going the wrong way, then let's go to the reverse. Once they're pointed the right way, then I can pick the opposite end. Okay, so we'll go ahead and accept that. Feed rate for the finish, let's slow it down to about 2 thousandths, max of 600. And then the max spindle speed, let's go on up to 3,000. We'll set a user-defined home position. I'll stay with the 5 and 5. From this tool, from this operation, from the rough to the finish, I don't expect to see one of those. See a tool change that I have to worry about that one. And then the finish parameters, 100,000, stock to leave 0, number of finish passes. So if we need spring passes, if we're seeing any kind of tool deflection, depending on the tool pressure, the sharpness of the tool, or we have a really ductile material that's going to flex through this thin cross section, we might want to have it repeat that pass once or twice to bring it to size. Our lead out, we'll extend out 150 thousandths again. We'll leave it with the angles and the lengths, those are fine. And still no plunge parameters to worry about. Finish direction along the z-axis, or if it's an interior bore, moving in the x-axis or moving in the x-axis from the other side. So I'm going to go ahead and accept. You can see the profile. Let's go ahead and hide this one. All right, so the first is going to, we're going to do the standard groove. And we want to try, again, we'll look at the geometry. So we have to decide if we're just going to do the one or try to do both. So multiple chains will allow us to do both items. If you're not sure about what the cutting conditions were, then do one chain, make a new operation. To do the second chain, we'll go ahead and try the multiple though. So I'm going to zoom in, pick my direction, pick where it leads out, and then we'll go right into the next entity and pick those for the multiple and accept. Alright, so I've got the 1/8 inch grooving tool. Feed rate of 2.5 thousandths per revolution, finish of 2 thousandths. Spindle speed, you want to keep this kind of on the low side. So if I were to bring this at 200, then the max spindle speed, I probably wouldn't want to run this over about 600 RPM. As we get into the tighter, smaller sections, really we're just giving the tool a chance to clear. We have that large surface contact area along the tip of the tool that we need to work from. So let's see, spindle speed on the rough is going to be constant surface speed, and then for the finish it'll be at RPM. So that doesn't seem too bad. Still don't want to be that far, so let's stay with something a little bit closer for the tool change home position. And then this is going to be the groove. Alright, so the groove shape parameters, we can use the stock for the outer boundary again, but still with this step it's going to kind of move up and over. And that's one of the reasons on the tool parameters that I picked this right facing tool, is it's going to be able to come up without gouging into the stock. Alright, so let's go ahead and use the stock for the outer boundary. And then the roughing parameters, when we set the cut direction, we have bidirectional alternating, so starting in the middle and working back and forth across the face. And then first plunge amount, 2 thousandths an inch per revolution. All right, we have a stock clearance of 100 thousandths, rough step. So the first one will be, tool going into the part will be full width, and then going to depth. And then stepping over, it'll go 75%, 75%, so there'll be more room for the tool to clear, or the chip to clear the tool. The stock to leave in X 5 thousandths and 5 thousandths will be okay. And then when we go into the PEC groove, we'll turn that on. And I'm going to leave this fairly shallow, so 10 thousandths of an inch for the PEC. And then PEC on first plunge only, so it would PEC in and then it would go straight in, step over, straight in. I want to turn that PEC on first. And this is also moving us towards that kind of safety. If I get in and find out that the material is being removed real well and I think I can plunge for those next passes, then I'll bring it up or possibly increase the depth. So at that surface speed per minute, as this makes a revolution, 10 thousandths is still going to pull up a pretty good chip, and I want to give it a chance to eject out of those grooves as it's being made, rather than generating one long stringy chip. Let's see what depth cuts is, and then how do we want to manage the depth. All right, so number of passes 2, moving between depths, zigzag, or retract to stock clearance plane, and incremental. So that would be one to check for. So are we going to PEC all the way in, step over, PEC all the way in, PEC all the way in, or in this case, step number of passes, so it would go PEC halfway, step across, come back, PEC to depth, step across. All right, so something that we can do with the depth cuts. Filter and well, let's see, filter. Looking for tolerances, look ahead, arcs, those items. And then the tool inspection, if we need to make sure that there is a tool still there after we get done. So I mentioned the cut direction, bidirectional, positive. So starting at the back, working to the front, starting at the front, working to the back, alternating bidirectional positive first. So start at the middle, work this way, come back and work that way. And then do you want to follow the chain direction where it would start and just go through the entire post? I think in the middle when working back, and depending on the material, I would probably end up using the depth cut. So I would say experiment with that one a little bit, see what you get. Each one of these is going to generate a lot of code though. So each one of these movements is going to be a separate line of code. There isn't really a can cycle for the lathe groove, or there isn't any simple way to have it do those plunge PECs other than generating each of the X moves. All right, and then the groove finish parameters. Oh, when I jumped over the groove walls, is it going to stair step down or is it going to try and make it smooth? That's an extra, and it depends on the rigidity of the tool if it's going to try and kick that insert over. So it, we'll go ahead and turn that one back off. It depends on if we have the clamp style or the insert just pressed in style. All right, complete all passes on each groove, and then direction, which way we want to go, number of finished passes, again, if we need a spring, overlaps, compensation, back off amounts, and the lead-in. So pretty much the same thing that we've built in so far. And we'll go ahead and see what we get. All right, so that gives us our geometry, and that should do for most of our shapes. The one that we wanted to try and came up was the dynamic. Put the insertion arrow up one, and we're going to create a toolpath for the dynamic rough. And the dynamic rough is going to use a button style. So when we did this before, it only allowed for one rough at a time. All right, so one relief, and then it jumped over and we said we're going to use the button. And what I found was that button tool was too large to get into the geometry, we have a 100 thousandths radius, 100 thousandths radius, and a 250 radius. So we need a tool small enough to be able to get in those radiuses, which was the 3/16 at 0.94 is still going to be able to generate that radius. So I had to go into the insert, and we're going to look at the we have the round, we have the IC diameter of 3/16, the thickness of 1/8 of an inch. Both of those were adjusted. And then nothing really to do too much on the holders other than make sure that the B distance, well, 5 inches, a little bit, oh man, that's the overall. C distance of 1.5 is deep enough to get into those grooves. And then what do we want to cut for or use for our cutting parameters? If we needed to add this to the library because we were going to use it enough, then we would save to the library and have it generate. So after we've modified that piece, set the user define, bring it in a little bit closer, and this is going to be the dynamic, and this is really an experiment. So the rough parameters, 50% step over, that seems pretty heavy, so let's go with a 20%. That drops it down to about 19 thousandths, about 0.5 millimeter. Toolpath radius is how much it's going to retract and come out and make that little loop. Stock to leave in X, stock to leave in Y. And if we zigzag back and forth with the round tool, it shouldn't have too much of an issue. The lead in, 180 degrees, and lead out. Don't really have any need for an extension there, so we'll bypass that one, just leave it as the standard. Plunge parameters, how it's going to get engaged, so basically both faces. For the side of the tool, I didn't leave a lot from that shank, so it's not really like it can go into the undercut without contacting something in that extension. So let's see, plunge parameters we just looked at, filtering on the faces, look aheads, and arcs, and we are in the remaining stock. So we go ahead and accept that. That's going to be my dynamic, and it's out here cutting quite a bit of air to bring it into those sizes before it comes in, and then we're still going to need to bring this back and make a finish pass. So I don't know that this is going to be any more efficient. It's a nice looking tool path, but if I could finish down this wall to the tangency, I could probably get this to clean up a little bit further, at least making the first cuts at this outer diameter. So that's what I'm going to need to experiment a little bit more with. And I reordered because the lathe groove removed all that stock, and we told it to look at the remaining stock. If this lathe groove is first, there's no material for it to remove. So we'll leave that in there for now. And if I go ahead and regenerate, so one of the things with the button and the sharp corners is I'm really not going to see dynamic, and we didn't really finish too much there. So let's go ahead and regenerate. Dirty operation. And since it did see, so apparently the stock is turned off. Well, let's go see what we got. Let's see, which one was that under. So it has the stock update, roughing parameters. Was expecting to see that in geometry, so yeah, didn't quite put it. Well, it's going to duplicate it, so that's fine. We'll go ahead and see what it looks like in the simulation, and I'll think a little bit more about what I'm trying to tell it to do here. All right, so everything's selected. We're going to go into the verify, and just really want to see what that dynamic's going to do. So let's slow this down. Okay, and then we hit play. All right, so the dynamic, and then the pack, and that went pretty fast. So let's go back over to our view. Let's see which one is it. I need the clipping, so we need to turn on the clip from the top plane so that we can see inside. Go back to the front view. I thought I slowed that down quite a bit, but apparently not enough. We're going to rewind to the beginning, and we'll hit play. So it's still pretty quick, but it's removing the material. And then our dynamic comes in, and wow, that looks, that doesn't look like there's a lot of wasted moves. And that one can go a little faster because we're going to be here for a while. Alright, and then the grooving, which is the one I really wanted to see. Alright, so it's kind of coming in. Oh, that didn't clean up as well as I expected. Alright, so it's going to do a little bit better on the non-curvy surfaces. There we go. So it comes in. Alright, so that's looking better. And so apparently the dynamic left a little more material than I expected anyway. Alright, so we're closer. That's going to require a little more tweaking of the operations, but that gives us a good start. And then when I go to post this, the one thing I want to look at, I'll go ahead and accept. And we'll let it replace. And get the code. So wherever it came up out. Okay, there we go. Get it going. Alright, so we have our first couple of passes, the facing, the roughing, and we get to the dynamic experiment. And there's quite a few moves there, but probably not as much code as I expected. And as we scroll down, I'm going to see, well, that is still quite a bit of code. And we'll look for that groove. Basically the groove's going to come in and start removing all of the material. So there we go. The OD groove brings in, has all of those X moves, moves over a little bit in Z, repeats the X moves, and as we bring it in, it's removing that material and giving us our clearance to make the geometry. So it is still quite a bit of code, depending on how much you set those steps. And this program ended up being 1,000 lines of code. So quite a bit of geometry there to cut and work with. If you want to add the cutoff, then bring this around. Make sure my insertion is at the end. And we'll go ahead and let it do the cutoff. And the boundary point can be the back of the part. Now this is leaning towards the front. I don't know that it has enough on the, let's see, on the insert. Cut that one. Now that I've hit all of them 3 times, we have enough extension on E, 1/2 inch. Not enough to go 1.4, so that'll need to be at least, well, let's make it 1 inch so that it has the clearance. For the holder, then we would have to set C on the holder, which does kind of the same thing. So 0.75, well, that would get us to 1.5 inches, so that would be alright. So, and then the parameters, we'll let it set, and then the cutoff tool. Alright, so constant surface speed of 2000. As it gets very close to the center, I really don't want it spinning that fast. So we're going to set a max of about 600. I don't know if I have a part sketcher. I don't know, what the condition is, if it's going to drop into the bottom of the lathe. I don't want it spinning too fast. So that may even end up being slower. Or on the cut parameters, we're going to allow it to set back, so 100,000 century amount, and then incremental retract radius of 100,000. So this is right now telling it to plunge all the way in, and then no corner radius. Alright, so if I turn on the PEC, then this is where we can have it clear that chip 10 thousandths and hit OK. Well, let's see, that was okay, so that one didn't show up on the lead in, lead out. Okay, and then there was one more, the X tangent point. If I wanted this to stay remaining to the connected to the part, rotating mass and all that, I could leave this in. We could take it over to the bandsaw, cut off the nub. If I did that, I would also want to add a little bit to the back face of the stock so that I could chuck this up in the lathe the other way and clean off that face. All right, so we're going to let that part through, and then that material will come off of the stock. All right, I think that is pretty good for now.